The second film on fluid pressure is about different pressure sensors. And the first principle is the so-called Bourdon Tube, named after Eugène Bordeaux, who lived in the 19th century. What the principle is that you have a tube here, which in many cases is C-shaped. And if you see the cross-section of the tube, it's kind of oval. And when you apply pressure to the C-shaped tube, and it's airtight in the other end, it's open in one end and airtight in one end. And when you apply pressure to it, this oval will go more round. Of course, I've drawn it in an extreme way here. But when it goes round, the C shape straightens out like this. And what you end up with is a relation between the straightening of the C shape and the pressure. So this is connected via some gears to a gauge here, giving the number that corresponds to the pressure. And of course you don't need to connect it to a needle like this. You can have, for example, here you could have strain gauges to detect the straightening, or this could indeed be a potentiometer instead of a needle, which would make you able to detect the resistance instead. This reminds us of a party flute, actually. When you blow pressure into a party flute, the flute straightens out, and the idea is to detect that straightening. Some Bordeaux tubes are formed in a spiral, like the picture here, in order to get more movement in the center of the spiral, or helical like this, which also gives more movement of the centerpiece. The second principle would be to have a diaphragm pressure meter, and a diaphragm is very much like a membrane, but the diaphragm does not let through any of the fluid that comes here. So the diaphragm separates the fluid that comes in here from the chamber here. So in this section here you will have the reference pressure, and in this area here you will put in your pressure to be measured. When the pressure increases here, the membrane shifts upwards, and when the pressure goes down, the membrane will go back down, or the diaphragm. That in this case is connected via gears to a needle, but it could also, of course, be potentiometer or whatever. What you have is a piece of sheet metal, which is circular in most and maybe all cases. You need precise dimensions in order to have a linear and nice repeatable instrument. Flat or corrugated, this case here, it's corrugated, where you have this wave pattern on each side, which improves the ability of the meter to move. It can be coated or covered with a foil. In case you have fluid here that is, for example, corrosive, then you would like to have the membrane or the diaphragm to be coated so that it doesn't wear out due to the corrosive material. This is self-draining, it said, and that is if when you apply a force, a pressure, and then stop applying it, it will drain out from the pressure sensor itself. Going back to the C shape here, maybe if you apply a fluid here, maybe some fluid will be left in the C shape at one end, and therefore will not drain out. And also with this shape here, this will not drain out by itself. Also, if you apply gas, for example, and the gas maybe condensates someplace in the C shape, well, that the liquid will stay in the meter, but in this case, the liquid droplets will drain out. Good sensitivity for low pressures. Capsule meters, same as membrane or diaphragm, but they are not self-draining, but they have double sensitivity. So you gain the double sensitivity, but you offer the not the self-draining idea. So you could have a convex capsule where the wave pattern here is opposite of the one on the lower half, or you could have nested, which tends to be more resistance against overpressures, and you can have a stacked capsule, which gives more sensitive device. Bellow, Belg på norsk, is a system where basically based on the same, but it inflates much more. Compared to a diagram, it generates larger forces. Moderate cost, delivers high force, adaptable for absolute and differential pressures. You can use it for both kinds of meter, and good for low to moderate range. Disadvantages: you need to compensate for the ambient temperature, because if you have a gas inside the bellow, the gas will expand as the temperature goes up. So you need something to compensate that. And then it's unsuitable for very high pressures, because that would destroy the bellow itself. Capillary tubes is a setup where you have a vessel here, and inside the vessel you may have, for example, a corrosive liquid or something that may form icing and so on. Then what you do is that you have a membrane here, and you have another liquid in the tube itself. So there is no contact between the tank liquid and the pressure gauge itself, because you have a midsection here where the pipe is filled with another liquid or fluid. You can, for example, use it when you have highly viscous medium, which will meet too much resistance in the tube itself. Mediums that may crystallize or freeze, mediums that contain solids, corrosive mediums where you have very high temperatures in the tank, or when sanitary cleanness is required. For example, if this is something for the food industry here, it's very difficult to clean the pipe here. For example, if this is used for milk, some milk will go into the pipe, and that milk will be contaminated with bacteria and fungus. And therefore, if you have a membrane and another media here, you can simply clean the inside of the tank, and that will clean everything that is in contact with the milk itself. So when you select a meter, make sure you find one that suits your measurement range, your accuracy, the materials you use. You have to decide where you want a diaphragm seal, capillary tube or not, if you want to avoid a contact between the meter and the tank liquid, vibrations and shocks, and also if you have a pulsating pressure, so because sometimes the pressure is absorbed by the meter itself. Then finally you have something called an accuracy class, which describes what error margin you can expect from your meter. So an accuracy class of 4 has much more error margin than an accuracy class of 0.1. So that illustrates the percentage. Do not mix that with accuracy grade. Grade and class, two different words. accuracy grade has numbers 4A, 3A, 2A, and up to D, where D is the least accurate one with the highest error margin, while 4A is the most accurate one and used for laboratory precision test gauges.